is Ryan Howard. I'm with Submer. We offer a turnkey immersion cooling solution that is an industry leader. We can cool up to 361 kilowatts in a very small portion of the space. So we're shrinking data centers down from 100,000 square feet down to 10,000 square feet.
We built a HPC data center strictly for high performance computing. It's 14,000 square feet with 14 megawatts in it. And so basically, it's all full of high performance computing systems that do parallel processing, a lot of power, a lot of cooling, a lot of heat generated, and it's to support the mission at the labs for our capabilities. I'm looking at our roadmap, a 5 to 10 year plan for our data centers. We're getting ready to possibly build a new data center and also improve on our existing data center. So we're always looking at new technologies out there. Now, immersion's not new, however, it's new to Sandia. So basically, we wanted to test this system in our data center, in our environment, to see how well we could adapt to it. After testing the equipment, we're basically going to just do a case study, which is about 2 pages. It doesn't talk about the results of that, but what we decided to do is kind of tell a story about the history of all the cooling systems out there. So I've been at Sandia 44 years, and basically about 34 of those years I've been around the computing world. So I've seen all the cooling systems develop over time and had a little bit of hand in each one of those at Sandia and actually nationwide. So basically we wanted to tell that whole story and build it up to the testing of the immersion system as you move away from mechanical cooling, which is chillers, and how closely coupled the liquid is to the heat source. So now you can't get any more closer than dipping the computer in liquid.
So the paper that Dave has come up with, I see it as the industry Bible to looking at air cooling, direct to chip, and immersion. So there's been a lot of confusion in the market as to new technologies and where to go. The paper that he's written really steps through it in both a written and a pictorial standpoint. So really everybody could read through it and understand it in their own kind of method of learning. I recommend they go through it in its minutia, and it's I can't say enough good things about how detailed it is in such a short period of time. I was joking with Dave that he could sell it on Amazon as a bestseller, because it is a fundamental primer, not only immersion cooling, but the other cooling technologies out there. And how do you cool a data center? How much energy? Everybody's always concerned with powering the servers, but they don't understand how much energy it takes to chill those servers. And the fact that if you're doing a ChatGPT search, you're burning through a glass of drinking water every search you do, which is pretty amazing. So it's one of those papers that really is informative, and it goes through the use cases. And I believe those use cases, as we talked earlier, will drive rapid adoption in the market, because it's simple, it makes sense, it reduces energy, and it is very cost effective.
We've had some copies out of the paper right now, but we're tuning it up. We saw some things we wanted to change once we submitted it. So we're going to do an amendment to the paper, and we'll have it out probably at the end of next week. And so it'll be out on the Sandia site, a website, and Submer and Addison and people like that were working with us on this project will also have copies of the paper as well. So this is basically HPC's liquid cooling. You can look around here. 5 years ago, there was one place that sold cooling solution, and now it's probably 80%. Something to do with liquid cooling. So you can just see where it's all going. Yeah.
So what's coming up in the future is a next generation system that is what we call directed flow, where we have a combination of immersion plus we can do directed flow into the processor or GPU itself. So we're achieving dissipation powers of orders of magnitude based upon legacy air or directed chip. So with this new system, as Dave was pointing out, you can take all the heat that you would normally have coming out of a data center just coughing into the air, which if you think about reaching around at home to your air conditioner on the outside and feeling the amount of heat coming out of your air conditioner, A data center puts out about 1 billion times that much heat. So right now that's being wasted, putting it up into our atmosphere. And we're having tremendous storms and all sorts of problems. It's not great for the environment. So what Dave has mentioned is the heat reuse, I think, will really drive a lot of the adoption of immersion cooling, because you can be a municipality and have all your sidewalks never ice up, have all your roads never ice up. And with water's the main cause of potholes in roads and having to change out these freeways, because when it freezes, it expands and it cracks the roads. So having this, you wouldn't need snow plows, you wouldn't need salt on the roads. It saves municipalities a ton of money. And tied to that, I see that municipalities and hospitals that have made, even financial centers that have made the move to the cloud are recooling, because they're seeing massive bills. So if you're a healthcare site and you have a $10 million a month cloud bill, that starts to get pretty painful. So you can put one of our immersion pods into your parking garage or orphan space that's no longer used in commercial real estate. And you can take that pod and you could use it for heating inside the building, or you can, at the same time, use it for roads and sidewalks around municipalities. And so you're doing two things. You're reducing the cost of government expenditures and private expenditures, as well as you're maintaining your roads and the lifespan of those roads. And other uses, such as farming, for example, you could farm 365 days a year with the waste heat. So right now we see the future being sort of an adoption of a kind of a peanut butter and jelly combination of, I have the heat in the data center, need to get rid of it. And then there's certain industrial processes, farming, roads that need the heat and can use that heat. So I see it being a really good solution for the environment.